Problem 12.5. Suppose we use x following the exponential distribution with theta as a parameter as the test statistics. Now we just have one random sample to follow this distribution, and I want to use it to as a test statistic to do the following test. So the theta minus theta equals to theta 0 is the null hypothesis, and the alternative hypothesis of the theta is equal to theta 1, where theta 1 is some number greater than theta 0. So remember that right now there are these are two simple hypotheses. And we're going to reject H0 when the x is larger than some k. So now the question is to find the expressions for the probability of the type 1 and type 2 errors. Okay, so now this is the test statistic. X follows the exponential distribution with theta as a parameter, and x greater than k is the critical region. So now we just need to first realize that the exponential theta has this as the PDF, where x has to be greater than 0. Okay, and now the alpha is the probability of the type 1 error. Type 1 error is that the x falls into this is the test statistic, and it falls into this critical region or rejection region when the null hypothesis is true, right? That is the probability of the type 1 error. So this is what we need. And now this is just that the theta is the theta 0, and then we want to figure out the value of this probability. K is greater than k. So we just take the integral of the PDF, where theta is set to theta 0, as assumed by the null hypothesis, and take the integral from capital K to positive infinity. And then we'll plug in this PDF here and take the integral. It turns out to be this value. And similarly, for the type 2 error, the type 2 error is the probability that x falls into the acceptance region, meaning that x is less than equal to k, assuming that the alternative hypothesis is true. The alternative hypothesis says that the theta should be equal to theta 1. So assuming that theta is equal to theta 1, the probability of this guy here is just the integral of this with theta equals theta 1 over interval 0 to k. So taking the integral of this PDF, where theta is equal to theta 1, over this interval gives us this result.